Good afternoon, everyone. I'm Shota Deolusegun. In today's video, I want us to dissect proving formula of everything. Now, we're going to actually see how we can, prove unification of quantum mechanics to classical mechanics, because that is what formula of everything is all about. So, once we are able to achieve that, we can get to know what quantum gravity is. So now what we want to have as our theorem will now be the unification of quantum mechanics to classical mechanics, and that is going to be the fact. So we want to actually reach a point where we can unify quantum mechanics to classical mechanics. Now we're going to start with the proof. The proof is we're going to see how we can have a kind of verification, and that verification is going to be in form of mathematical fact, because whatever statement we have or expression that we serve as our axiom, we want to model that in mathematical notation, so that we'll be able to actually have a mathematical model that can actually unify the quantum mechanics to classical mechanics. So now we know that the proof we want to do, that we want to achieve, has to be modeled. It has to be modeled in mathematical notations, so that it will actually facilitate the working process, the calculating process of the fact that we really want to derive. So now axiom is going to be a statement assumed to be true. So that is going to be the statement that we serve as the starting point, something that we trigger our interest, or that can actually boost our morale as regard the unification, something that is so close, something so close to the truth. You understand? Something so close to the fact that we can model mathematically and then arrive finally at our theorem, which is going to be the reached conclusion, and that is going to serve as the proof. So now, after the axiom, we're going to have logical process, and that is going to serve as a series of logical statements, each following from the previous. So we want to have a systematic process that will be in form of mathematics, that we can actually use to prove the unification. That is what the logical process part will entail. Now the theorem, just like I said, that is going to be the reached conclusion, and it's going to be the proof, and that is going to actually serve as what we intend to finally prove. So now we know that what we want to prove is that we want to prove if there is a possible or a feasible point where quantum mechanics can actually be unified to classical mechanics. That is what we want to prove. Now, so what kind of axiom can we have that is so close to that we can actually dissect and remodel mathematically for the purpose? And then the axiom is going to be H2O. We're going to use a molecule, yes, a molecule of H2O, which is water. We know that water can be in different state. So it can be in solid state, it can be in the liquid state, then it can as well be in the gas state. So we want to look at these three states. Well, we know that the states that are obtainable, are far more than these three states, but we're going to actually dissect these three states and see how we can then unify our quantum mechanics to classical mechanics. Now the thing is, when water is in the low temperature state, then we're going to have solid state where we have ice block or ice cube. You understand? So water will be so firm, and then it will become solid. But when that temperature is in the mid temperature state, such that the water is now transformed to liquid, then it becomes water. And that simply means that it is at the normal temperature. So from that, we can see that there is a kind of transition from the solid state to liquid state. And so we're going to, be, picking out all the necessary points to mathematically model the logical process. And so then when that water in liquid state, when it gets to high temperature state, then it will turn to gas. So then it will be in the gas state, and that is the state where the molecule is being broken down to its separate entity or constituent. So where we have oxygen being separated from the hydrogen, and then it becomes gas, then it can actually escape into the air. It becomes something we cannot see. Now we can see that right from the solid state that we can see and interact with, to the liquid state, and then to the gas state. So from this scenario, from this expression, from this axiom, which is the statement that we'll assume to be true, we can see that, number one, there is a form of transition from one state to another. And by having such transition, it simply means that there is a likelihood or possibility of having transition from classical mechanics to quantum mechanics. That is that. Then another thing we discover is that we have a kind of movement or transition from ordered state to unordered state. So when we look at the unordered state, that we actually relate to, or it could be, that will be synonymous to a state of having high entropy. And by having high entropy, we know what that simply means is it's a state where radiation is generated, and so that means that it's an ordered state. And then we have the solid state, which is the ordered state where the temperature is very low. So that we have like two, we're going from one extreme, front to extreme end, and so we can actually model that. So by having ordered state and unordered state, it's a kind of symmetric formation or symmetric condition. So now basically we know that the unordered state is going to be an inverted version of the ordered state if we're to model it symmetrically the way we envisage it to be. And so we know that yes, symmetry, we need to consider symmetry in our mathematical modeling. Then another thing that we need to look at is that there is a kind of, we see that as the molecule H2O is transiting from one state to another, there is a kind of energy usage. So, and we know that this kind of energy usage is within a period of time. So there is an interval of time. There is an interval of time peregrination. So basically, this, I think there is a kind of relationship, or a kind of a kind of relationship between energy and time. So we can say, we can model time energy, or we can say time energy model to actually include that in the logical process. So I think we have about 3 things right there. Then another thing is, if just as we have from one state to another, there is a kind of momentum, because before something can transit from one state to another, there must be a kind of momentum, and if there is, then there must be a conveying force. So what will that conveying force will be? We know that we have energy and we have a kind of interaction between time and energy. So definitely by having energy, then that means that there we might need to consider light. So speed of light will be involved, and if speed of light is involved, that means we need to treat and we need to consider the constancy of light speed in our mathematical model. So then, which other thing can we actually get out of this expression? Mm, mm. Okay, so as we proceed, we'll get some other things that we need as well. So we know that we have symmetry to consider. We know we have constancy to consider. We know that we have time energy interaction to consider. We know that we have yes, we know that we have asymmetric condition to consider. Asymmetric because the solid state is not the same thing as a gas state, so they are not. Yes, we know we have asymmetric condition nature to consider in our mathematical model. Then what else do we have to consider? Then another thing we need to consider will be because here I could see uh, I could see a trait of mass in this thing, because when we are in the solid state, it's something that we can actually measure and something that has weight. So it's mass, and even when it gets to liquid state itself, it's something we can measure, it's something we can actually interact with. So it has to do with state, with mass. Then gas state, even though we may not be able to see the gas state physically, but it's something we can interact with, and that too will as well have mass. So we need to consider mass too in our mathematical model, in our mathematical notation. So now we move to logical process. Now let's see how we can arrive at a logical process that we buttress what we're trying to do, which is the unification of quantum mechanics to classical mechanics. So now, if we have this inverted A, capital A, as for all, we have this inverted capital E as there exists, and then we have this normal E as element of, and then we have this inversely related arrow as relativity, and lastly we have this normal arrow pointing to right as implies, then we can use that to symbolically model the mathematics that we want to use. So now when we look at this inverted A, it means that for all time there exists energy. So that means that in the space that we're trying to consider, to the space in which we're trying to work out this unification, it means that the whole of time will as well have the existence of energy as element of time relativistic scaling to energy. So you can, as element of time relativistic scaling to energy, you can see that we have time in uppercase and E in uppercase. So we're talking about grand time and grand energy. So basically what we're trying to model here will be what can effectively explain the entirety of the universe as we have it. And so that is why we have this, because we're trying to explain the whole of universe, because the formula is going to be formula of everything. The formula we're trying to derive will be formula of everything. So now we have it to be element of time relativistic scaling to energy. You know that we have actually fashioned that out of the expression that there is a kind of interaction between energy and time. So now relativity, how are we going to model the relativity? That's another one interesting thing. Well, we know that relativity deals with time dilated relative to length contraction, and so it's going to be inverse. So it's going to be a kind of inverse relationship so that we will have here. So we now have such that this S dot T means such that for all of classical mass, which is m sub c greater than m sub q, which is quantum mass. So this is the ordered state. And so such, once we have ordered state, then we know that time relativistic scaling to energy has to be, time has to be dilated relative to length contraction of energy wavelength, or which whatever it is that is going to be. So then we have f of t to be greater than f of e right here. So then we have negation. Now negation we have here is not negation as in terms of mathematics. It is a negation like to say that is a dog, that is not a dog. So that is kind of negation that we mean here. So the first negation we have, because we're trying to model asymmetric nature of let me say asymmetric nature of the universe, because we want the formula to be something that we can actually use for any mass in the whole of the universe, because the way we see it is like, mass formation contributes to the expansion of the universe, you understand, and decaying of mass too will actually contribute to contraction of the universe. So now we now have the inverted version part, which is inverted asymmetric portion of the universe. So for all of energy, there exists time. Now you can see that that is an inverse of what we have here. Then we have that as element of time relativistic scaling to energy. So since we are still in the position phase, then time is still above the time trajectory is still above energy's trajectory. So it will still be time will still be here while energy will be here. So but we have a momentum phase where energy will be higher than time. So in that case, energy will be right here while time will be right here. So there is no need to flip time and energy in this case. So we still have it like that, but we know that the inverted phase is the contracting phase of the universe. So such that for all of classical mass, which is m sub c less than or equal quantum mass, which is m sub q. So then the function of t, which is f of t, is less than f of e. So basically, the reason we have this to be this is for the fact that energy will be increasing as it moves toward the central singularity, which is the center, which is the black hole, the center of the black hole. Energy will be increasing, and that is entropy. While here, time will be scaling narrow. So time will be scaling narrow relative to increasing energy. So now we have the inverted symmetric formation of the whole universe. So then we still have this mathematical notation where we have negation. This icon means negation. So for all of time and mass, so that will be there exists time such that it's not mass. So we're saying that time is not the same thing as mass. Yes, time is not the same thing as mass. Then we have another one, which means that this arrow implies that it is the same thing. So we have for all of energy and mass such that there exists energy such that E energy is the same thing as mass. So these are the mathematical notations that are modeling this expression, this axiom that we have properly the way they should. So we're going to use them to actually arrive at our the last state, yes, or stage, which is theorem. the proof. Now, the proof now is, we know that we have a kind of relationship between, time and energy. But basically, if we so now we have reached the final state, which is theorem, the proof. Now, the proof, if we look at this particular statement that we have here, which means that there exists such that energy is the same thing as mass. That is actually relating to constancy. And then we have time such that there exists time such that not mass. So time is not mass. So basically, we can say that mass is an emergent formation, and so mass is going to be so flexible, and so we're going to model our differential calculus as dt dm. The reason we're going to model it as this is that mass is emergent, so it's flexible. What we're saying here is that for any changes in mass will result to higher changes in time. So time will always be higher than the mass, no matter how that mass, increase. So basically, then the dynamics will, expand the universe as we have it. So we're not going to use energy, because energy is going to be constant in a way, because we're going to use speed of light as conveying force, and so we're not going to use energy. So now we have dt dm equal to capital Um plus 4m. Now, if you really want to know more about how this formula is being derived, I have a video in my channel. You can click you can get to my channel and click on the video and watch that video to understand how the formula is derived. So now, where we have this capital U to be the constant speed of the universe, which is 2.5 times 10 raised power 39. So by applying this formula, we're going to have what we have here, and this diagram that we have is known as a time energy wave model. Time energy wave model is actually, visually representing the kind of interaction between time and energy. And as you can see, they are being inversely related. This is energy wave. You see that it's traveling inversely to time energy. And so right now, we have time trajectory to be the classical portion, while the energy trajectory to be the quantum realm. So now, by the time we apply this formula is going to stretch energy beyond its limit threshold. And when it gets to the point of spontaneous symmetry breaking, then we have to annihilate zeros. And by annihilating zeros, we have this vertical line right from where the weak conveying force, which is 4m, is suspended at classical realm to quantum realm. And so we have this vertical bar. So that simply means that the trajectory is instant. But now look at the trajectory that we have here. Don't forget that this formula is a linear formula. And so we should have, linear model of it. But we're going to extrapolate this to have the wave as we have it. To say is so now, by having this vertical line, that is constant speed of light, and so the value we have to represent amplitude of wave, so which is 5.7 times 10 raised power 48 at classical level. Then we have 5.7 times 10 minus 48 at quantum level. Now, by the time here we have a mass worth of electron here, 9.109 times 10 raised power minus 31. Once we put this in the place of m in this formula of everything, we're going to get the classical mass worth, which is 2,277 250,000 kilogram. Now, the thing is, before we can actually get this mass of electron, the vertical bar, this vertical line, has to travel beyond the time energy it has to travel beyond the constraint of time energy wave model. And so that simply means that there are boundary at the edges of the position phase and then the momentum phase, these two phases. So there are boundaries, just as we have boundaries when there is nuclear fusion. When it gets to a point where deuterium and tritium will merge, you see that the repulsive force will be more intense, and then they have to override that repulsive force in order to merge. And when they merge, they form bigger mass, which is helium. So we have boundary at the edge, and so that the same thing is applicable to a situation where you have a proton being accelerated close to the speed of light. When it gets to the edge of the limit of the speed of light, then you see it being converted to mass. And so we will need, if once we have the necessary temperature and force, we can even go beyond the speed of light as well. So now, by this model, it shows that time speed is faster than the speed of light right here. Now the thing is, within this time energy wave model, the constancy of light is being maintained, so maintained that even when it is so stretched that we have redshift at this point where we have spontaneous symmetry breaking, at this point you can see that we have traveled beyond the asymmetric nature of time energy wave model. And that simply means that the asymmetric nature is needed to get the actual mass worth of electron. So if we put this wave amplitude in our formula, we're going to get a very tiny electron, and that is the electron's worth while in motion, and that is 0.00000001423. So that is so tiny. So to get the real mass worth of electron, we need to travel to higher dimension where there is higher degree of freedom and power. So where there is more space, because mass formation has to do with spatial space. It is visible in spatial space, not in a narrow space. So when we have spatial space, we have mass formation. But when we have a contracted phase or a contracted space, then we have energy density. So now that we have this, then this another vertical bar represents the constancy of light speed. But light is still being stretched beyond its limit to have redshift. And when it is so weak, then we travel beyond to higher dimension, and so we have the asymmetric nature of the universe. So this is actually modeling the entirety of the universe. And you see the phase where we have time scaling narrow. Here is time. We have time scaling narrow relative to high energy. There we have energy density. These two formations, they are energy densities, while these two formations are mass densities. So that is that. So then with that, we can get to know that the transiting point is the point of spontaneous symmetry breaking. So the proof now is quantum is unified to classical mechanics at the point of spontaneous symmetry breaking. So now we are able to finally prove our theorem, which is the proof. So basically, that is how formula of everything is being proved. That's how it is being proved. I believe that this video is quite informative and insightful. So if you really like the video, make sure you like the video for real by clicking the like button, and then don't hesitate to share this video with your friend. Make sure you subscribe to this channel so as to be notified for the subsequent videos. Then it's a novel discovery. I'm going to put the link to my research publication in the description below, so anyone can actually click on that, use the formula to arrive at all that we have on the board. So thank you. God bless you.